In a potentiometer experiment, null point is obtained on 7th wire for a given cell. Means if I say the EMF of cell is E, then according to principle of potentiometer, this E is directly proportional to the balancing length, or EMF of cell is equal to K into L, where K is called potential gradient, and the formula for potential gradient is K equal to I sigma into balancing length L, or it is equal to this current in potentiometer is given by EMF connected across potentiometer wire divided by resistance of potentiometer wire plus resistance connected externally in series with potentiometer wire plus internal resistance of a cell, and sigma here it represents resistance of potentiometer wire divided by length of potentiometer wire multiplied by balancing length L. Now here we want to shift the null point from 7th wire to 9th wire. Means the initial balancing length for given cell, it is somewhere between 600 and 700, and we want to shift that null point from 7th wire to 9th wire. Means we want to increase the balancing length so that its value will be somewhere between 800 to 900. So as E is directly proportional to L, E is directly proportional to L, and E is equal to K into L1. So whenever we want to increase the balancing length, it means this potential gradient, it must be decreased. See here carefully. Initial balancing length is on 7th wire, means L is somewhere between 600 and 700 for a given cell, and we want to shift that null point from 7th wire to 9th wire so that new balancing length is somewhere between 800 to 900. So to increase this balancing length L, this K must be reduced, and this potential gradient K can be reduced by decreasing applied EMF, means option B is correct. At the same time, this potential gradient can be decreased by decreasing or by increasing the resistance in the main circuit R plus R dash plus R. This is resistance in the main circuit, it must be increased in order to decrease potential gradient. Means D option is also correct. So whenever we have to shift the balancing length or balance point from 7th wire to 9th wire, means we want to increase the balancing length, and this is possible only when K is reduced, because for a given cell we are not changing the EMF of a cell. So to keep EMF of cell unchanged, if we want to increase balancing length L, then K must be reduced, and this is possible when there is decrease in applied EMF and increase in the resistance in main circuit. So here both the options are correct, B as well as option D is correct, and CET has given full credit either for B or for D on that year of examination.